Okay, so in the previous video we looked at how to determine from a set of data if we can create a polynomial, and if so, what the degree of that polynomial would be. Well, in this video we're going to look at if it is possible to create a polynomial, what would that polynomial end up being? So we're going to take it one step further in this video. So to begin with, you want to make sure that if you're following along and taking notes that you get this table written down in your notes. You don't need all the other information. But while maybe you're copying that down, I'll read what we're doing here. It says there's a classic math problem that asks how many different handshakes are possible in a room with n people. For example, 3 people would have 3 handshakes. 4 people, however, would not have 4 handshakes. They actually have 6 handshakes, and that's what they're illustrating here with these dots, that these 4 people would shake hands, and then these diagonals, these people diagonally from each other would also shake hands. So there'd be a total of 6 different handshakes. If we had 5 people, there'd be a total of 10 different handshakes. If there were 6 people, there'd be a total of 15 handshakes. 7 people would have a total of 21 different handshakes. So we want to figure out if there is a polynomial that would fit this data, and if so, what would the degree of that polynomial be? So to do that, we're going to do the same thing that we did yesterday. So we're going to find these differences. So 6 minus 3 is 3, 10 minus 6 is 4, 15 minus 10 is 5, and 21 minus 15 is 6. Do this again, since these weren't the same difference. 4 minus 3 is 1, 5 minus 4 is 1, 6 minus 5 is 1. So the fact that we have 3 of the same numbers in the second difference here tells me that this is a degree of 2. So therefore, if it's a degree of 2, this is the form that our answer is going to be in. Our form is going to be y equals, since it's a degree of 2, it's going to be ax squared plus bx plus c. Now here's where it starts to get interesting. Since there's, so I know this is the form that my answer is going to be in, I want to figure out now what my values for a, b, and c will be. So since there's 3 different numbers I'm trying to find, I'm going to use 3 consecutive pieces from our table. So here's the way we're going to start it. We're going to start by actually using the largest number on the right, because here's what this means. When I put 5 in this equation for x, again, we're trying to figure out what a, b, and c are, but when I put 5 in this equation for x, it results in giving me 10 as my answer for y. So if I get 10 as my answer for y, what I'm going to do is I'm going to put 5 in here for x, so 5 squared is 25, times a, plus I put 5 in here for x, so it'll be 5b plus c, because again, a, b, and c would be some numbers that would end up giving me 10 as my answer. So when I get 6 as my answer for y when we put 4 in for x. So I'm going to put 4 in for x here, so 4 squared is 16, so it'll be 16a. Put 4 in for x here, so that'll be 4b plus c. And I get 3 as my answer when my values for x is 3. So I'm going to put 3 in for x, so x is, when 3 squared is 9, so it'll be 9a. Plus when I put 3 in here for x, I'll have 3b plus c. So that's just getting it all set up. Now I'm going to use this. Right now this is 3 equations with 3 different variables. I want to break this down to be 2 equations with 2 variables, and then break that down to be 1 equation with 1 variable. And here's how we're going to do that. I'm going to start by finding the difference of these first 2 equations. That's why I want to set this up where my start out with the 10 first. If I put the 3 first, if I started out with my smallest number, when I go to subtract these, it end up with negative numbers. So that's why we started with the 10. So when I subtract these, now I'll have positive numbers, because 10 minus 6 is 4. 25a minus 16a is 9a. 5b minus 4b is just 1b, or just b. And c minus c is 0, so we're done with the c's. Well, this one down here, this equation's feeling left out, so we want to include him, so we're going to tie him in with the one above it. So 6 minus 3, we're going to subtract those 2 equations. So 6 minus 3 gives me 3. 16a minus 9a, well, that's 7a. And 4b minus 3b would end up being 1b, or just b. And the c's, c minus c is 0, so the c's are gone. So next, I'm going to take and subtract these 2 equations, because like I said, I started with 3 equations with 3 different variables. I've just worked my way down to 2 equations with 2 different variables. And now I'm going to I want to break this down to be 1 equation with 1 variable. Watch what happens when I subtract these. 4 minus 3 is 1. 9a minus 7a is 2a. And b minus b is 0. So the b's are gone. So now I'm successfully gotten down to 1 equation with only 1 variable. So now to find out what a equals, I divide each side by 2. Well, that gives me 1/2. So I know my value for a now in this equation is 1/2. Now my next step is to figure out, well, what would my value for b end up being? So I'm going to work my way backwards now. So I'm going to take and put 1/2 into either one of these equations that are in green here. So I'm going to put it in the second one because it looks like that would be easier. And half of 7 is 3.5, so now I have 3 equals 3.5 plus b. And if I subtract 3.5 from both sides, I get negative 1/2. I'm going to put it back as a fraction. If you had it as a decimal, that's fine, but it'd be negative 0.5 or negative 1/2. So now I know what a and b are, so now I can use those 2 values to figure out what c is by plugging a and b into any one of these 3 equations. Well, since I have the choice in which one I want to use, I'm going to use the smaller one. So I'm going to use the last one. So again, a is 1/2 plus 3 times b, which is negative 1/2, plus c. Well, half of 9 is 4.5, and negative 1/2 of 3 is negative 1.5. And now I'm going to solve this for c. Well, I can simplify these. 4.5 minus 1.5 is 3. And if I subtract 3 from both sides, I get c is going to be 0. Now, it's really easy to just think that we're done here, but remember, we're going to use this form to write our final answers. So I just found out what a, b, and c are, so we're just going to plug those numbers in here. So my final answer is this. It's y equals my a, which is 1/2, times x squared, you get that from right here, plus b times x, so b is negative 1/2, so it's going to be minus 1/2 times x, plus c. Well, c is 0. If you write plus 0, that's fine, but we can just leave that off. So your equation would be 1/2 x squared minus 1/2 times x. We can always use this equation to verify the numbers in our table here. Let me just move this up so we can see both at the same time. So here's our equation. So I'm going to plug, let's say if I use 6. If I put 6 in here for x, I should get 15 for y. Well, 6 squared is 36. Half of 36 is 18. If I put 6 in here for x, well, half of 6 is 3. And sure enough, 18 minus 3 is 15, which is what we have here. So I just verified that that should be the correct equation. Okay, so let's try another one. This time they don't even give us any table, they just give us some information here. It says square tiles are used to construct a square patio as shown in the diagram. Find the polynomial function that relates the total number of tiles to the number of rings. We'll let the center tile be ring 1. Okay, so here's what we have. We have this scenario where we have the number of rings. And we have the total number of tiles. The key there is the total number of tiles, not just the number of tiles in that particular ring, but the total number of tiles. So we have a total of 4 rings here. In the first ring, well, we just have just that one tile in that first ring. In the second ring, they're referring to, well, how many would there be in that area total, including the first ring that we had, plus the second ring. So we have a total of 3, 6, 9 tiles with that second ring. With the third ring, we're trying to figure out how many total tiles there would be here. Well, it's a square that's 1, 2, 3, 4, 5 tiles by 1, 2, 3, 4, 5 tiles. So 5 times 5 is 25. So there's a total of 25 tiles when we add a third ring. When we add a fourth ring, there's a total of 1, 2, 3, 4, 5, 6, 7 tiles by 1, 2, 3, 4, 5, 6, 7 tiles, which gives me 49 total tiles there when we add a fourth ring. So we want to see, is it possible to create a polynomial here? And if so, what would the degree end up being? Well, 9 minus 1 is 8, 25 minus 9 is 16, 49 minus 25 is 14. Oops, 24. So now we're going to find these differences. 16 minus 8 is 8. 24 minus 16 is also 8. So that means this again has a degree of 2. So that means the form that my final answer is going to be in is this: y equals ax squared plus bx plus c. Now some people have asked, well, how do you know what form it's in? So here's one way to look at it. If the degree is 1, it's going to be in this form of just ax plus b. If it's a degree of 2, it's going to be in this form ax squared plus bx plus c. If it's a degree of 3, it's going to be in this form ax cubed plus bx squared plus cx plus d. If you notice, you can see a pattern here. The degree is going to be the highest exponent, and then the exponents go in descending order. So 3, 2, 1, none. The coefficients, we start with a, and then just go up from there. So a, b, c, until we end up with just the coefficient without a variable. So a, b, c, and d. That's why this one is a, b, and c. That's why this one we just have a and b. So it's a second degree polynomial, so it's going to be in this form. So again, if it's a second degree polynomial, that means that there's a total of 3 different numbers I need to try to find. So I'm going to use 3 consecutive pieces from our table here. So I'm going to use these 3, and you want to set up now a system of 3 equations with 3 different variables. The first equation you start out with is always the largest one. If you don't, you can still get the same answer, it's just that you're going to work with negative numbers. And so a lot of times that's where people make mistakes. So here's an easy way to do it. We know that we get our answer of 25 when x is 3. So I'm going to put 3 in this equation. Well, 3 squared is 9, so it'll be 9a. Put 3 in there for x, that'll be 3b plus c. Put 9 in there for x. We get our answer for 9, I'm sorry. We get our answer of 9 when x is 2. So we put 2 in for x. Well, 2 squared is 4 times a. Put 2 in for x, so that's going to be 2b. And then there is no x with that last one, so it'll just be c. We get an answer of 1 when x is 1. So 1 squared is just 1, so times a. 1b, or just b, plus c. So this is your system of 3 equations with 3 variables. Why don't you guys pause the video now and try this one on your own, and hit play when you're ready to check your answer. So here's what you should have done. Subtract these. 25 minus 9 is 16. 9a minus 4a is 5a. 3b minus 2b is just 1b, and the c's are gone. Subtract these. 9 minus 1 is 8. 4a minus a is 3a. 2b minus b is b, and the c's are gone. Subtract these now. 16 minus 8 is 8. 16 minus 8 is 8. 5a minus 3a is 2a. Subtract the b's, those are gone. So now I can divide both sides by 2 to find out that a equals 4. Now I can put 4 into any one of these 2 equations. I'm going to put it in the second one. And solve for b. Well, you get 8 equals 12 plus b. Subtract 12 from both sides, you get negative 4. By the way, some people have also asked, are these always going to be opposites of each other? No, that's not always going to be the case. It just so happened to work out that way with the last couple of examples. But now I'm going to put a and b into any one of these 3 to figure out what c equals. So let's try the last one. That looks like it'll be easy, because it'll be 4 plus b, which is negative 4, plus c. Well, 4 plus negative 4, or 4 minus 4 is 0. So I get c is 1. Remember, don't stop there and say that's your answer. We should have had your final answer then is going to be y equals your a, which is 4 times x squared, plus b, which is a negative 4 times x, plus c, which is 1. So there's your final answer in standard form. And again, you can always use that to check your final answer, but we'll just stop there. So that's how we solve these problems. That's how we can figure out an equation by using a table. by using what we learned about yesterday and using this technique. But hopefully you know enough now to do your assignments. So with that, good luck.